Hi, I'm Rahul, and welcome to another episode of Bob Friday Talks. AI is often regarded as a black box, or magic. Demystifying AI can be done by explaining how AI is built and developed. Today I'm joined by Bob Friday, Chief AI Officer here at Juniper. Today, Bob will be walking us through how to train your AI. Thanks so much for being here, Bob.
Thanks for having me.
Let's dive right into some fundamentals. So, what is a data scientist and what's their role?
You know, Rahul, what I always tell people, data scientists are like unicorns. You know, you're looking for someone who really understands statistics and math and can also write production software. These are not easy people to find. If you look what we missed, the first data scientist I hired was actually a particle physicist, someone working on physics experiments and looking for signals in these big physics experiments. Very similar to what we're doing in networking, trying to find a signal and a lot of noise. Another great example is a data scientist who is actually working on modeling protein molecules and amino acids. And he was doing that up to the point until Google DeepMind actually solved that problem with deep learning. You know, so these are people who actually understand hardcore math, statistics, but can also write great production software. These are actually very hard people to find.
So how does protein amino acids actually relate to the building of AI? Because I've heard this come up a few times in my conversations with other people, and it's never been quite clear to me, like, how does those two things link?
Well, you think about the protein problem, right? You know, they've got all these amino acids. They're trying to predict the properties of proteins based on how amino acids join. There's billions of different combinations here. Before deep learning, they were actually trying to solve this problem with simulations. You know, they were actually going to linear accelerators to get X-rays to actually look at these protein molecules. What Google DeepMind did was actually be able to train these deep learning models now to predict the properties of a protein molecule, knowing how the amino acids join. So that's a great example where deep learning is actually making a difference in the medical space.
So tell us, how do you train your AI?
Yeah, you know, when you look at AI models, they come in different flavors. You know, the basic ones start with what they call supervised training. This is where you have labeled data, where you know the answer. You know, and this is what OpenAI and ChatGPT is doing when they train ChatGPT. They're taking tons of data off the internet to predict the next word in a sequence of words. You know, what we're doing in networking is like with Zoom data. We're taking Zoom data, combine it with network feature data, and we're building models now that can predict Zoom latency and user experience. So that's an example of supervised training. Self-supervised training is where you look back on existing data, like anomaly detection, you know, where we're looking back for the last week, months, to actually predict the next 10 minutes or hours based on data we've seen in the last past. And that's what we call supervised training. And then we get into reinforcement learning. And this is where we're basically training models based on awards, you know, where we're basically looking to optimize the user experience on the wireless network. And we're creating a symmetrical, trying to optimize the symmetry between the user and the network. So that's an example of supervised, self-supervised, and reinforcement learning that we're working on.
How long does it take to train the AI?
Yeah, you know, training models varies quite a bit. You know, you look what they're doing at OpenAI and ChatGPT, that's millions of dollars, weeks and months worth of training on these big, large language models. If you look what we're doing here at Juniper Mist, really we're probably training on the order of seconds and minutes, you know, whether we're doing a big supervised training model, which may take minutes if we're looking at all the data across a universe of networks, or we're doing some training on a site level where we're looking back for the last week or months, right? So yeah, training can range anywhere from seconds to minutes to weeks, depending on how big these models are you're training.
So a term I've heard a lot in conversation come up is AI inference. Can you tell us a little bit about what that is?
Yeah, when they say AI inference, what they're really talking about is actually running a model in production and getting an answer. You know, when we train these models for like LLM, right, we may actually spend more time and expense training the model than actually running an operation. You know, when you look at our LLM, Marvis chatbot, you know, we may have to train it on hundreds of thousands of questions and answers, whereas when we actually put it into our actual network, we may be dealing with only hundreds of questions or thousands of questions per week. So you can think about training and inference. Inference refers to actually running the model in a production environment.
How do you measure the effectiveness of an AI model?
Yeah, I think there's a couple answers to this question. When a data scientist trains like a supervised model, they'll typically take a training data set, they'll take 70% of the data to actually train the model, and then they may save 20 or 30% to actually measure the effectiveness and how accurate that model is. So that's one technique or definition of effectiveness from a data science point of view. From a customer-facing point of view, here at Juniper, we actually run our models in our customer support team, and we do something called Marvis efficacy, where we basically have actual users grade our models and tell us how often the model is getting the right answer. So you could think of effectiveness at the data science level when you're training your models, and then there's actually the customer-facing effectiveness, how effective it is with your actual customers or the problem you're working on.
Thanks so much for your thoughts today, Bob. We really appreciate your time, and thank you for listening, and until next time.